Hello, everyone. So today we have quite controversial topic, like Terraform is that long-life Kubernetes API. It's enough controversial that Thomas scolded me on LinkedIn about that some time ago. Today we will talk about alternative like the Terraform, and if we can replace Terraform, if there is some replacement for the Terraform, and if Kubernetes can play a role in that. So how looks like typical app deployment with most companies? So we have happy developer who produce some code, create a commit, and this commit should start some CI/CD process. So we build the code, test the code, push artifacts, make some security scan if needed, and deploy an environment or inside the Kubernetes cluster in cloud in most ways these times. But problems starts when we need some new, our application requires some new infrastructure element. So we have new feature, it requires connection to the new infrastructure element, and we want to make the developer to still be happy and do this fast. But in most cases, it's not possible because our infrastructure is run with the Terraform, which is not totally user-friendly. So what that kind of deployment looks like when we have some infra element to deploy. So we one more time have our happy developer who create the commit with the new feature. And then what? There is two paths. One path is he contacts the DevOps engineer, and DevOps engineer adds some code to the Terraform in the repository, run some process to deploy that. Or if our developer is quite handy with the DevOps tools, he can do this by himself, and as end of this, we will see the new element of infrastructure, and the whole process go like the same way. So how the Terraform doing this? So if you want to deploy something with the Terraform, first we need to new Terraform manifest. Then we have Terraform init, which can consume time to download each packages, especially if we wrap this inside the CI/CD, because caching is not always working, or some dependencies is changing. We need to Terraform plan to see what will happen, and then Terraform apply, and at the end we have our new piece element of the infrastructure. So Terraform is a good tool, but it's not perfect in that way because it requires some manual steps from us. We don't see the drift. So what we have, what the pros or the pluses of the Terraform is. So Terraform is widely known. For now, most industry of the IT using the Terraform to deploy the infrastructure. So it's very common, very well known, very popular, even inside the corporation, because the corporation in most cases is the guys who change their approach at the end, because they have some standards, they used to use the standards, and when we have some new trends, they wait when these trends get stable and then start implementing itself. So now the Terraform is the standard. It's inside the corporation. Also, the Terraform has very big community. We have plenty of the operators created by the community. Big support from the HashiCorp itself or the community. So it's very handy and it's very encouraging to work with that tool, but also have some minus. And one of this is the HCL. For the regular developer who is focused on providing some code, features, products inside his language, learning HCL only to provide some piece of infrastructure is very unsupportive. He don't want to do that. Why he need to learn this to deploy something or something like that? Then the next case is no API. Terraform does not have an API which we can connect, fetch some data, fetch some information. No, there is no something like that. In some cases, Terraform can have long execution time. If our infrastructure get bigger and we don't have some good splitting between the state files, the executions can take even minutes, long minutes, and also is rated with the plugins or modules which need to be downloaded or uploaded, so it also took time. Lack of state awareness. So Terraform by design is not aware if our infrastructure is changed. If someone log in directly to the cloud, make some changes on site in our infrastructure, which was deployed with the Terraform, Terraform is not aware of that to the moment when we execute one more time plan. We can do that cyclically. We can create the job, but it's not very efficient. And changes visibly only during the apply. So how we can handle with that minuses? Oh, I forgot. There is also the recent problem with the licensing of the Terraform, because Terraform changed the licensing. We have the new product like the OpenTofu. Also, if I remember correctly, the HashiCorp was bought by IBM. So there is the risk of changing the licensing and make the Terraform as a paid product is rising. So how to live with that? The answer is, in my opinion, is the crossplane. So what crossplane gives us? Crossplane gives us, like the Terraform, possibility to deploy the infrastructure in all big three cloud providers with the help of the Kubernetes, Argo, and Helm. It depends how we implement this. Why is so different from the Terraform? First of all, crossplane exists inside the Kubernetes. So if we want some piece of the infrastructure new, we need to deploy new Kubernetes manifest. As most developers who work with the Kubernetes know that the manifest is right in the YAML. So we have the one language for the create new deployment of their applications and for the deployment of the infrastructure, which is very handy and leave the burden of learning the new things from the developers. It also gives us API, which we call and fetch some data. It's very nice work with the Argo CD and have some other features, which is very crucial, like the detection of the drift of the infrastructure. It's using the commonly known mechanism which exists inside the Kubernetes, which is called the reconciliation loop. How the reconciliation loop working? So we have the controller. I assume that people who work with the Kubernetes know what the controller is. If not, the controller is piece of software which control some object inside the Kubernetes constantly. Crossplane also using this mechanism. So controller creates something like which is called control loop, which is infinite, and create checking two things. One is the desired state. Desired state is if we apply our manifest to the Kubernetes, this is our desired state. But the state can be changed, and there is the current state. So these two states can be different from each other, and the reconciliation loop and control loop is tasked to check two of them, compare them if they are the same, it goes, sleeps, and go to the next turn to check the same. But if they are the different, if there is a difference between two of them, controller try to adjust current state to the desired state. Of course, there can be problems because, like always, not everything works fine. But this is this mechanism is out of the box inside the Kubernetes, and control plane is simply using this mechanism. I don't have many slides, so we go to the juicy part and presentation. How it works. So I have prepared Kubernetes cluster, which only have Argo CD installed for now. And we go the whole path and show how crossplane can work with that. So the first things we need to achieve, if the size is okay, everyone is seeing? Okay, great. So first of all, we need to install the crossplane. We use this with the Helm. The process should be quite fast with the installation. Yes, we have installed the crossplane. And we see that crossplane is installed. This is these two pods, and with the crossplane we get something which is called CRDs inside the Kubernetes. So you know what is it. So this is shipped with the crossplane, and this gives us the opportunity to configure the crossplane also inside the Kubernetes cluster. So the next step is the configuration. How we configure the crossplane? First of all, we need to decide which provider we used. I will use the GCP, so I pick the GCP providers, and I say what I need. I need the provider for the storage and the cloud platform. So to apply them, okay, they are in place. Now we can check the version, or if they are installed, get providers. Yeah, they are installed. But someone can ask, okay, I show only 2 providers, but I have 3 providers. So at some time ago, the crossplane decided that because maybe on the way, these providers also create the CRDs. And with these CRDs, particularly these ones, we can create new element of the infrastructure. So at some point, crossplane only have 1 provider, but with that approach, this one provider create whole of bunch of the CRDs, hundreds of them for only 1 CRUD provider. And this can affect efficiency of the Kubernetes. So they decide to split this for the particular topics like the storage, networking, cloud platform, IAM identity, yada, yada, yada. So we pick from what we want to choose and what we want to operate, and install only this selected. That's why we only have this small amount of the CRDs. And we have 3 providers because these 2 are children of that one. So this is install automatically when I say that I want to work with the GCP. So we have our providers. Now we need to configure our providers to work with the cloud. To do that, I have deployment runtime config and service account. Service account is element of the Kubernetes standard one, and deploy runtime config inject this service account to our providers. Why I'm doing this? Because provider itself don't have any relations with the cloud. So I need to give this access from our providers to the cloud. I'm using the GCP mechanism called workload identity to achieve that, and this configuration apply this mechanism to the control plane, cross plane. Okay, it's configured, so it's in place, and the last step is to say to provider config about this service account and how he should, which credentials he should use to talk with the cloud. So okay, so our pieces are in place. So we can start with creating something. To show that I'm not cheating and there is nothing before I apply something, we start with the bucket as a primary one. So I don't have any buckets for now. So I simply go. And apply buckets. How this definition looks like. So I use the storage GCP upbound API version. I say that I need the bucket, kind bucket, and this is some natural to the Kubernetes. API version is natural to the Kubernetes kind, metadata, and spec, and everything what is inside is specific to the crossplane. So I put the name in the metadata of my resource. I put the external name. This name is the same name, but this name will be used to name the bucket, because it's not necessarily need to be true that the object inside the Kubernetes can have one name, the other inside the cloud can have other names, and I provide some information for the provider, like the location, storage class, force destroy, and deletion. So it should, yeah, the bucket shows. So everything is going well. Also, we can check this information inside the Kubernetes cluster. Get bucket, and we see that we have our bucket is synced. It's ready to use. It shows external name. We can also go with the describe. We have full events, how it was going to deploy. We have statuses of everything. And what I want to show you now is the drift detection, on which I mentioned already. So imagine the situation that the bucket is not the best example, because bucket mostly have the data, and if someone delete this, we'll lose the data, but it's silly example, but it's work. So imagine that we delete this. Or instead of bucket, we can imagine that we use of the VM, and we need to wait a little bit we can go get we need to wait to like you see, the status is changed, that the bucket is not exist on the side of the cloud, so the synchronization get failed. So the reconciliation loop already noticed that something is not right. So if we go to the describe, we see on the describe that something goes wrong, and control crossplane will call the Google API to one more time create this bucket. So like I mentioned, the bucket is not the best example, but imagine the virtual machine. We have the configuration of the virtual machine inside the crossplane, and someone goes and deletes this. It took the minute to give it back. We even can no notice about that, so it's very handy in some ways. Also, it detects the changes inside the configuration. We can go see the configuration and see that for example, default storage class was declared as a standard one. So when I change it, for example, for the nearline, save, it go back to the standard one. So the crossplane detect the drift and simply turn it back to the desired state, which is very handy. But at the beginning I mentioned about it should make the developer work easier. To make it happen, we also need another piece in that puzzle, which is GitOps and Argo CD. So the Argo CD is already installed. Argo CD is already installed, so I show you how we can utilize Argo CD to make some deployments easier. I prepared some manifest to the Argo CD. Argo CD, when it's installed, is also create some CRDs inside the Kubernetes, and we can utilize these CRDs for our advantage. This one is application, is using some pattern inside the Argo CD, which is called app of apps. So we apply this one, and this one pointing to this repository, to the particular path, and inside this path we have some other manifest which point to this one. But we only need to apply this one, only this one, and all others will be fetched automatically and deployed automatically, which is very handy. So to show this, it's created. I show this on the Argo CD site. So we apply only one, and we have 3 elements. So it's very handy. And imagine the situation. With all of this, we get some silly application. The application is very simple. It don't have much logic. It's only show the string "Welcome to Cloud Native Warsaw," which we can see that is valid. And imagine the situation that is our application, we have the new feature, and the new feature is to connect this application to the bucket because it requires some storage. So how we can do that? We go to the repository to this application, and I have prepared some Helm charts to enable this. So we have two additional Helm charts, which we are uncomment and show you. The first one is the service account, and the second is the bucket. Service account create the service account inside the Kubernetes, and the service account inside the GCP for the purpose to give access to implement worker identity, to give access to this service account from the Kubernetes to connect to the bucket. And we have the values files. In this file, we define the every values to implement this approach. This is already filled up front. So first of all, like I mentioned, I need to get service account to connect to any bucket. So I comment this code. Push changes to the repository. Can go to the Argo CD, click refresh to make some things make faster, and we see that Argo CD detect the change inside the repository, see that we use the new Helm, and deploy the new elements. So in this case, it deployed the service account, which will be used inside the cloud. And here also we have the conditions, we have the statuses. We can check inside the cloud that service accounts. If the service account is created, yes, the bucket app service account, which is the same how we define two. Okay, so we have the one element of the puzzle. The next one is the bucket. So we back to our repository, uncomment the bucket, repeat the procedure, and like you see, the bucket in this case will be the new one, and the name of the bucket will be GitOps show up one bucket. So we go to the Argo CD, refresh our changes, and again we see new elements shows up. New elements shows up, and it's still waiting for the creation. So it took a little bit about a minute to create that, but you already see that everything is configured from the repository. It's the perfect way for the developers to maintain the applications or configure something. They don't need to know the Terraform. They don't need to know the cloud. We provide only the tools to them, explain how they work, explain how to create the config file, the YAMLs, and they do all the work by themselves. It took about a minute, so we should see the bucket in seconds. Not yet. Okay. And in the meantime, I do the last step. As the last step, we need to teach our applications to start using this bucket. I prepared some script which use the same, which use this name of the bucket and should connect. So we have the new bucket. I refresh. We change the application, so we should see the new revision of the pod. Exactly. The pod is created with our changes. And if we go to the bucket, we should see the new file which is created and upload. So everything is work. We create service account. We create the bucket. We create all dependencies and give opportunity to bucket to talk to application to talk with the bucket. You can imagine that it can be applied to almost everything inside the cloud. It can be database, PubSub, and others. We can create whole projects inside the GCP. Networks, all of that can be started from that one place. And that's all. If we go with the demo, the crossplane also have some other feature which is very handy. It's called the composition, but this topic is very extended and it's not enough time to cover this up. But I only can say that we can leverage up this functionality, and because now I am using the Helm to create the manifest dedicated to the crossplane, which we can observe here. Like service account, bucket IAM, everything what is managed by the crossplane, we can see we see it here, and the composition leverage this to that we create own API, and this one API can create everything. It can create the application, database, schema, ingress, services with only one single tiny manifest. But like I mentioned, the composition is quite advanced topic and require more time to show it. Okay. So Terraform is dead. Long life Kubernetes API. This is true or not? At some point, I can assure that Terraform is not dead yet, and probably will not be dead quite long, because, like I mentioned at the beginning, big companies start using Terraform, and it took a long time before they resign from it and replace it with something new. But crossplane is a new thing which can also do the same thing, maybe a little bit better. Also have some downs, some cons in some aspects, because compared to Terraform give us control about what we deploy, because like you see, detection drift working almost instantly and autonomous. What if we change what we don't want to, or corruption changes? We can destroy our resources. So it's double-edged sword, but it's implementable. It's very handy. Work with the Kubernetes, very good. So we have only one place of the truth at some point, and that's all. So the question will be open a little bit longer, and questions.
Hey, yes. So the first question is about disaster recovery, and I'm curious whether have you observed any patterns emerge in the community with regards to the GitOps approach? Because I think there's one big issue with, for example, Argo CD. If you use Argo CD to create your crossplane manifest, right? And let's just imagine that you need to completely get rid of your cluster and you recreate it, then first of all, Argo CD will try to recreate those manifests, but those resources are already created on the cloud provider side. So this is one difficulty we have with the disaster recovery. The second difficulty we have is how do you reliably back up the crossplay manifests themselves? Whether you think something like Velero is accurate enough to persist our etcd state. So again, the same case, if we just completely want to remove our cluster and start fresh and still have the same infrastructure, then so yeah, those two questions, like what to do about the Argo CD recreating crossplay manifests, and what is the reliable tool to back up the crossplay manifests themselves?
Okay, so there is the different approach. Like you mentioned, we can back up the whole cluster and simply recreate the cluster from the backup in some new region or something like that, and it should recreate everything in place. I think the AWS have quite good story about crossplane and disaster recovery. The other approach is everything you have inside the GitHub repository or Git repository. So your only concern is to have cluster and configuration of the crossplane, and the crossplane configuration is not necessarily be stored or backup, because if you have also the configuration inside some repository, you can simply apply it to any cluster, and the same go with the Argo. Argo configuration can be applied by the config map. If we have backup of the config maps, we can simply apply to the cluster, and the new instance of the Argo automatically fetch the changes and go connect to the repository and create everything from scratch if needed.
I mean, with crossplay, I'm afraid it is not correct, right? Because when you create objects using crossplane, they get assigned unique identifiers. So unless you stored the objects which were, created with the operator.
It also depends. I understand, but this depends how you understand the disaster recovery, because you can understand this that way. Your cluster with crossplane is crashed, and everything else is working in this place. In that case, you're right. This can be the problem. I don't remember. Crossplane have something to attached to already existed resources, so it shouldn't be the problem. But also we can, the disaster recovery can stand for the whole region go down. So to recreate everything. And in that case, the manifest inside the repository should be enough.
Yes, in that case, yes, but I'm mainly concerned with taking over the control over already existing resources, but in automatic way, right? Not to specify those IDs manually or import them. But yeah, anyways, thanks for the answer.
Okay. Hold on. Who was the next? I saw your hand, no? Okay. You will be next.
Yeah, the minus of the crossplane is which need to be started, the first one, I assume, yes?
I mean, the chicken and egg question is already answered. Like, there were lizards before the chickens, so yeah, the egg is first, of course. Yeah, but my question here is like, okay, you just conveniently say, oh, I have here a Kubernetes cluster, it's running already. So like the premise of Terraform and having a Terraform is cool, because I could start from scratch, having a manifest, deploy that from scratch, and having something created, basically maybe EKS or something like that, and have to do the same with crossplane, basically.
Okay, it's fair question. There's a couple ways we can combine Terraform with the crossplane itself and put Terraform only for initial creation of the cluster, and everything goes with the crossplane. And we have the other solutions like the cluster API. There is SIG project which is called about. It can spawn the clusters.
Yes, but you still need the cluster to be able to
Looking at this, for Terraform, what we know is that the moment you have your Terraform manifest and you have your state file, you are good, right? But with the introduction of crossplane, do you think it's better to have like a dedicated cluster that is responsible for your infrastructure provisioning? Say, for example, you have like on a large scale, you have a very, huge environment. Do you think it's better to do that? And at the same time, is that not creating extra, workload and other things on the operations team?
So it always depends how we trust our infrastructure and capabilities and how it can manage. It's not simple. There is no simple answer for that. It always depends on the case, how your company, how your project looks like now. So in the very robust, crossplane should work very fine. I have.
I'm saying that you need to have like a cluster that is dedicated for your infrastructure provision. Because for Terraform, you only have your
It depends on you totally. If you decide that it's better for you to centrally manage the infrastructure, you can go that way. If you decide that you can split it to the different cluster, for example, you can split this for the environments like dev, test, prod, and dedicate crossplanes cluster in that only entities to create resources only on that space. It always depends on your needs, on your, for example, security policies, how you create your architecture. So it always depends.
All right, many thanks. Big round of applause to our speaker.